So we have started things with very simple questions from Newton's laws of motion. But for the some questions, we were not able to apply Newton's law of motion directly. So therefore, when you have two or more forces, right, we have to apply some other theory. Listen here. I'm just today is a very important day. You have to listen to me carefully. So let me give a very simplest thing here. Simplest example that can be written for Newton's laws of motion is that's an object of mass 10 kilogram. Let's say we have applied the force of 2 Newton. Simplest thing that we can ask is what the acceleration. Right? To find the acceleration, this is the simplest question that can be asked under Newton's laws of motion. Right? Yeah, let me change the whiteboard, then you will be able to see it. Right. Now you can see it, right? So this is the simplest example that can be given. To find the acceleration, the easiest thing is we just apply F equals mv. We just apply F equals mv. The force is 2, mass is 10, acceleration is 8. Take 10 to this side. 2 divided by 10 equals 8. Therefore, acceleration is 0.2 meter per square seconds. This is the easiest example. Even in O-level science, you may have answered this. It's so simple. The second thing that can be asked here, right? Let me take something like this. Let's say there are two forces. Just listen to me. Let's say mass of the object is 4 kilogram. Right? So let me consider two forces like 8 Newton and 2 Newton. There are two forces like acting on the object as 8 Newton and 2 Newton. They are parallel to each other and they are horizontal. The surface is also horizontal. Two horizontal forces are acting on the object. Object is moving on the horizontal surface. So if it is asked us to find the acceleration, again we can easily apply F equals mv. I'm just revising the things that you have learned, right? Revision is essential before we go to a new important section. Right? So listen to me carefully. Today I am going to explain motion along inclined plane and velocity time graphs. Before that, listen to me carefully. I am revising the things. Right. So if we apply F equals mv in this equation, F means actually the total force. But the scientific term is not the total force. Scientific term, not the total force, but the resultant force. Resultant force. Right? The resultant force acting on the object is, there are two forces, 8 Newton and 2 Newton. 8 Newton and 2 Newton. Both are acting in the same direction, parallel. They are parallel and acting in the same direction. Therefore, the resultant force or the total force acting on the object is the summation of the forces. Mass is 4, acceleration is 8. 8 plus 2 is 10 equals 4 times 8. So take for this side, 10 divided by 4 equals 8. It means 8 equals 2.5 meter per square seconds. So these are very simple, very easy to understand. The next thing is, right? The next thing is that's an object. Let me consider the mass of the object to be 20 kilogram. Now the situation is slightly changed. Here the forces are parallel to each other. Here the forces are parallel to each other, but now forces are not parallel to each other. They are not parallel to each other. Let's say the two forces are acting like, let's say this is 4 Newton and let me take this as 6 Newton and the angle between the two forces, let me take it as 60 degrees. Let's say it is given that resultant force is horizontal. Let's say it is given in the question that, let's assume that horizontal force is given to be horizontal. Resultant force is horizontal. Now there's a special theory to find the resultant force. What is that theory? Somebody unmute the mic and tell me.
Parallelogram law.
Parallelogram theorem of a
Parallelogram law.
by using the parallelogram theorem of vector addition, we have obtained an equation to find the resultant force. What is that equation here? R square equals
R square plus equals
R
P
square
square
equal P
plus
square plus
2P
Q square
cos
plus
theta.
2PQ cos theta.
very good. P square plus Q square plus 2PQ cos theta. So we have to select P and Q forces. So let me take 4 Newton as P and 6 Newton as Q. You can select as you wish. Right? So first of all, we should find the resultant force. Now, say in summary, because we have reached the end of this lesson, say in summary, let's say this is the summary, and write the three examples, calculate the resultant force and send your answer to my student. Write down everything, find the resultant force and send your answer to my student. Start here. Ramai, now I changed my mic. Can you hear me now properly? I changed the mic.
Yes, sir.
Right. Actually, I wanted to tell you that I was telling you that this is the simplest example that can be given under Newton's laws of motion. Simplest example. And this is the next step of the same example. Here only one force is there. Here there are two forces, but they are parallel and acting into the same direction. The third one is somewhat complex. The third one, the forces are not acting into the same direction. They are not parallel to each other. They are not acting on the same straight line. So we use a special theory to find the resultant force. That is known as parallelogram theorem of vector addition. That's what I have said. I think earlier my voice was not clear. I have changed it now. Right. See now, R square equals P is 4, Q is 6, 2 into P is 4, Q into 6, cos 60. Can somebody tell me what the cos 60 is?
Half.
Half. Very good. Very good. So this is 4 square is 16, 60 square is 36, 2 into 4, 8, 8 times 6. 8 times 3, 24, 8 times 6 means 40. 8 cos 60 is half. Now let's add 6 plus 6, 12. 3 plus 1, 4. With the remaining one, 5. 48 divided by 2 is 24. So this is 6, this is 7. So R square is 76. Therefore, R is square root 76 Newton. If you have obtained the answer up to this point, that's enough. Who got this answer? Please raise your hand up. I'll check in the Zoom chat. Please raise your hand up if you have obtained this answer. Right. No need to simplify this further. That is enough. If you approximately 8 point something, 8.6, 8.7, something like that. Right, now we know the acceleration. Now we can find, now we know the resultant force. Now we know the resultant force, so we can find the acceleration. You just want to apply F equals mv. Now the resultant force is R, mass is M, acceleration is A. We have found R as square root 76. Mass is 20 into A. If you take 20 to this side, square root 76 divided by 20 equals E. So please write the acceleration with the unit. Square root 76 divided by 20 meter per square seconds. Do not forget to write the unit. Who got the answer up to this level here? That is enough, no need to simplify. Please raise your hand up in the Zoom chat if you have obtained this answer. Okay, very good. Right. For this summary, I want to give you one more question here. For the summary, let me give you one more question here. Right. Let me edit this question. Let me give you another example. Say 3. Let's say mass of the object is 40 kilogram. Now the force acting on the object is like this. Right. A force of 20 Newton is acting on this object. It makes an angle of 60 degrees with the horizontal. Saying number 4, draw this figure here. This is the fourth and last one. So these are the things that you know under the forces.
Correct. Write them here. Draw the figure. Right. Now we use the theory that we learned last week, resolving a vector into two components. So I'll divide. A force is a vector, right? A force is a vector. So let me divide this 20 Newton force. The mass is 40 kilogram. Let me divide this 20 Newton force along two perpendicular directions, saying Fx Newton and Fy Newton. So Fx and Fy are resolved components of the 20 Newton force. Draw both figures together, right? Let's find Fx and Fy. After that, we can find the acceleration. Draw both. Right, what is the theory that we should use here? How do we resolve a vector into two components? So if we have a force of F or any other vector, force for any other vector, we have something like this. We can divide this force into two sections. If this angle is theta, the component of the force towards the angle, let's say Fx, component of the force away from the angle, towards the angle, to the side of the angle, away from the angle. That's how we remember. Towards the angle is cos. The component of the force towards the angle is cos. F cos theta. the component of the force away from the angle. This is the angle away from the angle Fy, that is sine. So this is Fy F sine theta. Don't shout. Right. Please write it there. Okay, find Fx and Fy and send your answers to my Zoom chat. Find Fx and Fy and send your answers to my Zoom chat. Start. Find Fx and Fy and send your answers to my Zoom chat there. Okay, some of you have sent me the answers. The force component towards the angle Fx is F cos theta. So here F is 20, cos 60, theta is 60, theta is 60. So this is 20 cos 60 is half, 20 divided by 2 is 10. Who got this answer? Raise your hand up in the Zoom chat. Okay, nice. Excellent. Then the force component away from the angle, sine. Towards the angle mean this, away from the angle mean this. Force component away from the angle, that is cos. So if y equals f sine away from the angle sine, f is 20, this is sine 60. So 20, what is sine 60 here? Lamai, match people. What is sine 60? Nobody knows? Yes. That is square root 3 over 2. 20 divided by 2 is 20 divided by 2 is 10 root 3. 10 root 3 Newton. Right, now we want to find the acceleration. To find the acceleration along the horizontal direction, let me apply F equals ma. So I apply F equals ma along the horizontal direction. So once we say that we are, listen to me, don't write, listen to me. Once we say that we apply F equals ma along the horizontal direction, we should take only the horizontal components. Once we specify a direction, we should use the things along that direction only. The only horizontal force component, the only force acting along the horizontal direction is Fx. The only force acting along the horizontal direction is Fx. So therefore, horizontal force is Fx, mass is 40, we don't know what the acceleration is. Fx was found as 10. Fx was found as 10. So 10 equals 40 times A. Take 40 to this side. 10 divided by 40 equals A. So 0, 0 can be cancelled out. 0, 0 can be cancelled out. Then we get A equals 1 over 4 meter per square seconds. If you divide this, you get 0.25 meter per square seconds. Who got this answer also without my help? Please raise your hand up. Okay, nice. Excellent. Yes, you should use linear motion book. Mechanics linear motion book. Under that we are writing these. Actually, this is just a summary. This is just a summary. Right, so now we have successfully completed the summary. Now we are going to start a new section. That is motion along inclined planes. Okay, now let's go to the new section. I think time is enough, but if you want any more time to write these things, please take a screenshot. I'm going to erase everything. This is the summary of vectors as well as Newton's laws of motion. So please take a screenshot if you want any more time to write the things, because I'm going to erase everything. I'm going to erase everything. Right. Write your new subheading, the motion along an inclined plane. Motion along an inclined plane, motion along an inclined plane, right. Motion along an inclined plane. Please write, let us consider an object. Under that, please write a description. The heading is motion along an inclined plane. Under that, please write, let us consider an object. Let us consider an object which is moving along a smooth inclined plane. Let us consider an object which is moving along a smooth inclined plane as shown in the following figure. Let us consider an object, which is moving along an inclined plane as shown in the following figure. Look at board here. Let's say there is an inclined plane, right? An object is moving along this inclined plane. Let's say this angle is 90 degrees. Let me take this angle as alpha, right? So an object is moving along this smooth inclined plane. What is the meaning of smooth here? Lamai, what is the meaning of smooth? Huh? Smooth means no friction, right? So let's say we have placed an object like this. The gravitation attraction force, which is most famous term, is weight. The gravitation attraction force is acting vertically downward. The gravitation attraction force is acting vertically downward as mg Newton, right? When an object is kept on a surface, whether it is moving or not, when an object is kept on the surface, whether it is moving or not, the surface gives a force which is perpendicular to the inclined plane. This force is said to be the normal reaction force. The normal reaction force. Right? Normal means perpendicular. Perpendicular to the inclined plane. When you place an object on any surface, whether it is inclined or not, when you place an object on any surface, that surface gives a force, and that force is perpendicular. It means this angle is 90 degrees, perpendicular to the surface. That force is known as normal reaction force. Right? So when now we can look at what now we can divide this mg force along two perpendicular directions like this. We can divide this mg force along two perpendicular directions like this. To divide it, the first thing, listen, how many forces acting on the object? The force given by the earth, gravitation attraction force, mg. And the force given by the surface, r. That force perpendicular to the surface. In physics, perpendicular is said to be normal. Normal means perpendicular. Now let me mark this angle as beta. Let me mark this angle as beta, and let me mark this as 90 degree. So my final wish is, look at what. The final thing that I want to achieve is, I want to divide this mg force along two perpendicular directions. Right? That's what I want. You see this, the force component towards the angle. What is it? Somebody unmute the mic and tell me. mg is the force. What is the force component towards the angle? Lamai? somebody has to unmute the mic and talk. Otherwise, class will not be started. What is the component of the force acting towards the angle? Yeah, can you try now?
MG
cos
cos theta.
theta.
mg
MG cos theta, sir.
cos beta. Very
Cos
good. Force component
theta.
towards the angle. Very good. Force component towards the angle is cos mg cos beta. Component away from the angle. Component
MC
away from the
sin
angle.
MG sin theta.
MG sin theta.
Sin beta. Very good. Away from the angle sin beta. Sorry. And let me mark this angle as theta. Let me mark this angle as theta. This is beta. This is theta. Would you please draw this figure? Now you please draw this figure, because if I give you a lot of descriptions, you will forget. Draw the figure. This is the inclined plane. The object is moving. I have marked the two forces. And please remember that whenever you mark the resolved components, you must use dotted lines. For the resolved components, use only the dotted lines. Okay, dear? Do not forget it. Use only the dotted lines. Start. Alpha, beta, theta. Draw the figure, and if you have any doubt, you can unmute the mic and ask. Right. Once you have completely drawn this figure, send the message to Zoom chat saying done, so I can give you the next part. Once you have drawn it, send a message to Zoom chat saying done. Right. Look at board here. If you consider these angles, this theta, alpha, and 90. If you consider this theta, alpha, and this is 90 degree, they are the internal angles of a triangle. If you consider this alpha, theta, and 90, they are the internal angles of a triangle. So we know that summation of the internal angles of a triangle is equal to 180 degree. So if I take alpha and 90 to other side, I'll get theta equals plus 90 come to this side as minus 90. Plus alpha comes to this side as minus alpha. Then you get theta equals 180 minus 90 is 90 minus alpha. Let me take it as equation number 1. Write it here. Summation of internal angles of a triangle 180 degree. I use that result to obtain an expression for this angle theta. Complete it here. Right now, look at board here. Look at board. What do you think about the summation of theta and beta? Can somebody tell me? If I add this theta and beta, what will be that value? Lamai?
90 degree.
90 degree. Very good. You say that this is again 90 degree. Can you see it? This is again 90 degree. So you must identify that theta plus beta is 90 degree. Right? So please write according to the figure. According to the figure, right? Theta plus beta equals 90 degree. But theta is, look at what, wait. But theta is 90 minus alpha. So in the place of theta, I can write that 90 minus alpha plus beta equals 90 degree. Right? So let me take minus alpha to the other side and 90 to the other side. In the place of theta, I have written 90 minus alpha. And now I'll take both 90 and alpha to the other side. So I'll get beta equals 90 plus 90 goes to the other side as minus 90 minus alpha goes to the other side as plus alpha. Now you see this plus 90 and minus 90 cancelled out, you get beta equals alpha. This is a very, very important result. You must remember that. So what is that result here? This angle and this angle beta are equal. Whatever this angle, whatever the angle alpha is always equal to beta, you must remember it. In the examination, no need to prove that alpha equals beta. You can directly use. No need to prove that alpha equals beta. You can directly use it. Complete here. Write a model. Right. Now I want to find the acceleration. That's the only thing I want to do here. I just want to find the acceleration. So mark the acceleration as simple A. After that, let's discuss few questions, and that is the end. Mark the acceleration. Acceleration of the object along the inclined plane is a meter per square seconds. So I'm going to do something like this. Along the inclined plane. Along the inclined plane to this direction, we apply F equals mv. If you consider along the inclined plane, what is the only force acting along the inclined plane here? Just look at this figure and tell me. What is the only force acting along the inclined plane?
mg sine beta.
mg sin beta.
Sine beta. Very good. The only force acting along the inclined plane is mg sine beta. So the only force acting along the inclined plane, mg sine beta equals mt. If you take m to this side, mg sine beta equals divided by n. If you take m to this side, equals a. So you get the acceleration along the inclined plane as a equals m to m cancelled out, g sine beta. That's it. Acceleration along the inclined plane is g sine beta. Completely clear? When some students unmute the mic and talk to me, sometimes I do not hear it. So if you have unmuted the mic and ask something, if you do not get any reaction from me, it means that I am not hearing you. The best thing is then send a message to the Zoom chat. When you ask something, if I do not reply you, the best thing is sending a message to the Zoom chat so I can help you. Can someone tell me the heading that I have given today? Somebody unmute the mic and read the heading that I have given today.
The motion along an inclined plane.
The motion along inclined plane. Thank you. After that, what I have given as a note?
Let us consider an object which is moving along a smooth inclined plane as shown in the following figure.
Okay, thank you very much, dear. Thank you very much. Could you please read the heading again and the sentence that I have given under the heading? Could you please read slowly again?
The motion along an inclined plane. Let us consider an object which is moving along a smooth inclined plane as shown in the following figure.
Thank you, dear. Thank you very much. Let us consider an object which is moving along an inclined plane, which is moving along a smooth inclined plane as shown in the following figure, right? So let me try for example. The most important thing that you should note here is this alpha and beta are equal. Whatever the value of alpha, it's always equal to beta. Therefore, you should not worry about this angle theta. No need to even consider this angle theta. Do not worry. Just mark beta like this and take that beta equals alpha. Just take that beta equals alpha. So it means actually, if you want, you can write one more step saying A equals G sine alpha. The sine alpha, the reason is alpha and beta are equal. If you want, even you can write like this. Right. Now let us try for an example. Let's say an object. Now you know the name of the force. Let's say an object starts to move. Let's say this object. Look at board. Let's say this object starts to move. Say this object starts to move along this inclined plane. Along the inclined plane. At rest, starts to move at rest. It reaches to the bottom of the inclined plane. The object reaches to the bottom of the inclined plane with the velocity of v meter per second. Let's say they have given us this point is A, this is B, this is C. So in some examinations they will ask, they will give you the length of the AC inclined plane, and they will ask the time taken for the object to travel from A to C and the velocity of the object when it reaches to C. So please write example. Example. An object starts to move at rest. Example. An object starts to move at rest. Along the top of from the top of an inclined plane. An object starts to move at rest from the top of an smooth inclined plane. An object starts to move from the top of an smooth inclined plane as shown in the following figure. An object starts to move at rest from the top of an smooth inclined plane as shown in the following figure. You can draw the figure later. You can draw the figure later. Let me ask you two questions. Some questions. Roman number 1, Roman number 2. An object starts to move from the top of an smooth inclined plane as shown in the following figure. Roman number 1. How long does it take for the object to reach to the bottom of the inclined plane? How long does it take for the object to reach to the bottom of the inclined plane? How long does it take for the object to reach to the bottom of the inclined plane? Within brackets, how long does it take for the object to reach to the bottom of the inclined plane? Within brackets, please write. The length of the inclined plane is 10 meters. The length of the inclined plane is 10 meter. The length of the inclined plane is 10 meter. Roman number two, find the velocity of the object, find the velocity of the object, find the velocity of the object when it reaches to the bottom, find the velocity of the object when it reaches to the bottom, find the velocity of the object when it reaches to the bottom. Right, this is the figure, but somebody unmute the mic and read the question from beginning to the end? Somebody unmute the mic and read the question.
Example, an object starts to move at rest from top of an smooth inclined plane as shown in the following figure. Roman number 1. How long does it take for the object to reach the bottom of the inclined plane? Within brackets, the length of inclined plane is 10 meters. Roman number 2. Find the velocity of the object when it reaches to the bottom.
Thank you, Ria. Thank you very much. Draw the figure. Mark the force component as Fx and Fy. You can select anything. If you want, you can take them as E1, Fa, and Fb as you wish. Fx, Fy, Fa, Fb, any numbers can be used. Draw the figure. Fa and Fb are the resolved component of mg forces. Therefore, you must use dotted lines. Draw the figure, find Fa, Fb, and acceleration. I think you can do it along without my help. Find Fa, find Fb here. This angle alpha is 30 degrees. So if alpha is 30, beta should also be 30 because alpha and beta are equal. You can directly use it. Alpha and beta equal. Alpha is 30, therefore beta should also be 30 degrees. Find Fx, Fa, and Fb. They are the resolved components. Find the acceleration. Find the acceleration. I think you don't want to know the mass of the object to find the acceleration. You just write the expressions for Fa and Fb by taking m as m. Then apply F equals ma, find acceleration. I think you can do everything without my help. Try it and send your answers to my Zoom chat. Do a try. Everybody should draw the figure. Then after that, you should start answering the questions. Everybody should draw the figure. After that, start answering the questions. Right. Many of you have sent me the answers. Let me give an effort here. Let me check. Let me check whether your answers are correct, because you have given a good effort. Right. If A is the force component towards the angle, if A is the force component towards the angle, therefore it is mg cos beta. And the first of all, look at board here. The first thing that you should understand that alpha equals beta, and alpha is given as 30 degree, therefore beta also 30 degree. So this is what you want to write. This is very important. But sometimes when this is given as 30, many of the students directly write this beta as 30. That is also correct. If this is given as 30, without writing beta, you can directly write 30 here, no problem. Right, then the force component towards the angle cos. So that is mg cos beta, force component towards the angle. So this is mg cos beta is 30. Right? So, and if you want, you can write like this: mg cos 30 is root 3 over 2. Right? We know that, look at board, this is n, we know that g is 10. We know that g is 10. So if you divide 10 by 2, you get 5. So m into 5 root 3 Newton is Fe. So this is the only thing that you can do with this, because m is not given. As m is not given, can only obtain an expression for Fa like this. Right? Who got this answer? Please raise your hand up. Who got this answer? Please raise your hand up here. Right. Okay. Very good. Then FB, the force component away from the angle, sine. Mg sine component away from the angle. So if B equals mg sine beta. M is m, g is 10, sine beta is 30. Can somebody unmute the mic and tell me what the sine 30 is? Am I?
Half.
Yes, very good. Sine 30 is half. So 10 divided by 2 is 5. So force component is m times 5 or 5m. 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 Unit cannot be written, or within brackets you can write like this. So this is the force component FB. Who got this answer? Who got this answer also? FB. Right. Very good. So what should we do next? Lamai, what should we do next? Somebody unmute the mic and tell me the next thing that we should do.
Should find acceleration.
Yeah, we want to find acceleration. To find the acceleration, what should we do?
Apply F equals ma.
Very good. We should apply F equals ma along the inclined plane. We should apply F equals ma along the inclined plane to this direction. What is the only force acting along the inclined plane?
FB, sir.
FB. The only force component acting along the inclined plane is FB. FB equals ma. We have found FB as 5 times m equals ma. So this m and this m cancelled out. 5 equals a. But normally we should write that a equals 5. Unit is meter per square seconds. Equals 5 meter per square seconds. Complete here. And who got this answer without my help? Who got this answer without my help? Now try to find the velocity of the object when the object reaches to C, and the time taken for the object to reach to the bottom. Find velocity and time taken. You were right here. Earlier we have proved that A equals G sine beta, but that is not a standard equation. Therefore, you should follow this method. You cannot directly write A equals G sine beta. You must follow the steps. Write them all here. Write them all. Now try to find velocity and time taken for the motion. Right. What should we do to find the velocity here? Or the time taken? Anything? What should I do to find the time taken or velocity?
Apply the equation v is
Very good. Apply the equation along the inclined plane. This is very important. You must say that you apply the equations along the inclined plane. Otherwise, no marks will be given. You must indicate this. Along the inclined plane, we can apply the equation S equal ut plus half AD square. Wait a minute. What's the length of the inclined plane? What is the length of the inclined plane?
10 meters.
10 meter.
So therefore, S is 10 meter. Initial velocity? What is the initial velocity?
0.
0. Time taken is the thing that we are going to find. Half. What is the acceleration of the object along the inclined plane? What is this?
5.
5. Acceleration of the object along the inclined plane is 5. Time taken for the motion, that's what we are going to find. Can you do the rest and find t here? Obtain the value for t. Even with the square root, it's okay. If the answer contains the square root, no problem. Find the value of t and send your answers to my Zoom chat. What's the time taken? This 10 equals 0 into anything is 0. Plus 1 into 5 is 5 over 2 times t square. So 10 equals 5 divided by 2 into t square. Take 2 and 5 to this side by cross multiplication. 10, 2 comes up, 5 goes down, and you get t square. I know that this 10 can be divided by 5. 10 divided by 5 is 2. 10 divided by 5 is 2. So you get 2 times 2 equals t square. Therefore, t square equals 4. It means t equals square root of 4. So it means t equals 2 seconds. Who got this answer? T equal 2 seconds. Who got this answer? Lamoy? Okay, very good. Complete here. Now we want to find the velocity. How do we find the velocity here? Lamai? How do we find the velocity?
By velocity, applying v equals u plus at.
Very good. We should apply the equation v equal u plus at, but you must say that you apply the equation along the inclined plane. So we should apply F equals ma equation along the inclined plane, right? We should apply F equals ma equation along the inclined. Sorry, not F equals ma. We should have. We want to find velocity, right? To find the velocity, we should apply the equation v equals u plus a. So initial velocity is 0. We found acceleration as 5. We have found the time taken as 2. 5 times 2 is 10. So velocity of the object when it reaches to the bottom of the inclined plane is 10 meter per second. Who got this answer? Lamai? Who got this answer? Very good. Right. So we should discuss more questions. Yes, I agree. But I'm going to start a new section, velocity time graphs, and from next week I'll discuss more questions for the motion along the inclined plane. I promise I'll discuss more questions, but let me start the new section, velocity time graphs and displacement time graphs. I'll start with I'm going to teach both graphs together, but let me start with velocity time graphs. Okay, dear. Right. Please write your next subheading or heading velocity time graph. Use the same book. Use the same book and write the heading velocity time graphs. Velocity time graphs. Velocity time graphs. Right. Under that, please write. Under that, please write. Heading is velocity time graphs. Under that, please write. Let us consider an object. Let us consider an object which is moving along a straight path let us consider an object which is moving along a straight path with a constant acceleration as shown in the following figure. Let us consider an object which is moving along a straight line path with a constant acceleration as shown in the following figure. Let us consider an object which is moving along a straight line path with a constant acceleration, comma, as shown in the following figure. Right. If you want any more time to write these things, please take a screenshot. I'm going to erase all these things. Let's discuss more questions for this section later. Take a screenshot. I'm going to erase everything. Right. Look at board. So I have asked you to consider an object, and that object is moving along a straight line path, something like this. Initial velocity of this object is u meter per second. It travels with an acceleration of simple a meter per square seconds. After simple t seconds, the object's velocity is v meter per second. Right? The time taken for the motion is simple t seconds. The displacement is s meter. Draw this figure